Hello, everyone. Thank you so much for joining us this evening. I'm just going to jump straight into a few housekeeping issues before we do any introductions. I'm really hoping that those of you who have joined us this evening can hear us. So if you are having any difficulties hearing us, or if we're dropping in and out, please just pop something in the chat box. As you can see, I've already written some information in there, but if you have any questions throughout the webinar, or you have any tech difficulties or anything like that, please pop a question into the chat box. You can either address this to everyone if you think we'll all benefit, or you can address it to us individually. We'll either get back to you during the webinar or at the end, and it should go for about half an hour. So my name is Kirsty and I am a prospective student advisor here at Flinders Uni. So essentially it's my job to help figure out if Flinders is right for you, find out what courses that we have on offer and how you can gain entry into those degrees. I'm also very lucky to be joined by Marissa this evening. I'll let you introduce what your job is, Marissa.
Sure. My name's Marissa. I am one of the STEM Outreach Communication Officers here at Flinders. My background is actually in computer science, so I look after everything that's sort of based at the Tonsley building, which covers all our computing, our IT, our engineering and our maths disciplines.
Excellent. Well, thank you so much for coming this evening. Marissa is definitely much more of an engineering expert than I am. So Marissa will be delivering a majority of the content this evening. But if you do have any questions about how you can gain entry into those degrees, pop a question in and we can chat about that at the end as well. So, to get started, Marissa, why should someone choose engineering at Flinders?
Because we're awesome.
Obviously.
So there's some really nice benefits to coming and studying with us. I already mentioned Tonsley, that that is our specialist campus for our engineering, IT, maths kind of disciplines. If you come and study engineering with us, you'll be at Tonsley from second year. So first year there's a lot of overlap with other STEM disciplines in terms of the topics that you take. So a lot of that is based at our Bedford Park campus. But from second year and up, you're at Tonsley, so you get to experience our specialised teaching and research labs. There's some very cool stuff down there that is tailored directly to the degrees that you'll be studying. The other really cool thing about Tonsley is that we have industry partners on site. So what that means is for you as a student, you've got opportunities the whole way through your degree to meet people who are really out there in industry, really doing it. So networking opportunities, but also opportunities to get involved in projects. So you really get some skills under your belt, prove that you've got what it takes. You can do all of that before you've even finished your degree. So that sets you up really well before
and that's
you finish.
A nice way to help get a job at the end of your degree as well.
Exactly.
What everyone wants.
Yeah. Another thing that we do that really helps you strengthen up your skills through your degree is your work industry learning placement. So we have a compulsory 20-week wheel placement for engineers. Most other places do about a 12-week one, but we find a 20-week lets students not just settle in and get a sense of things themselves, but actually start giving back to the company that they are involved in. So again, proving that you've got the skills, building up those relationships with industry, all of that sort of stuff. We actually find a lot of our students get their first jobs from that 20-week placement, which is pretty amazing.
Oh, fantastic.
We have a lot of support in place during that time, so you'll have someone back at the uni who'll be supporting you through that. You're not just chucked out there and expected to go it alone. You've got that support, you've got that connection, and that placement can be done locally or it can be done interstate or overseas. It depends what your goals are and where you want to head. We negotiate those things and work it all out.
Excellent.
I guess the other thing there that I haven't mentioned yet is you also have the option to combine degrees. So you can actually combine any 2 degrees from the College of Science and Engineering. So it's really, really broad. There, if you have a look through the various brochures and guides, you'll see that there are some named, suggested combinations, but it's even more flexible than that. So something to keep an eye out and that we can chat about if you've got multiple interests in the STEM space.
Excellent, thank you. So I understand that we have a number of different specializations within engineering. What do we have on offer and what does the honours part mean as well in this? Because I noticed that was listed on every degree.
Yes, it is. So engineering has always been a 4-year degree. That means that honours is compulsory. It's combined into that 4 years. Honours is basically a research-focused year, so you'll do a large-scale project. Again, you'll have a supervisor and support and stuff through that, but it helps prepare you for research-oriented work. So that's still, it's not just to prepare you for, say, an academic career, that's also really highly valued in industry, so that's why we keep it in there. So that combined with your 20-week industry placement really means that you've put a lot of your skills to use during your degree. You're not just learning the theory, you're actually using those skills and practicing it and making sure you know what you're doing. It's also a really good opportunity to practice your project management skills, which is very transferable to pretty much anything that you might do after university. So it's a really worthwhile year there. So we have all sorts of different specialisations. You can see them listed out here: biomedical, civil, computer and network systems, electrical, electronic. We keep those ones separate, even though they're quite related, but I'll talk about that a bit more in a minute. Mechanical, maritime, robotics and software engineering. We also have a 3-year design, technology and innovation degree. So if you're interested in the business side of stuff, perhaps you're looking to create your own product or service, you might like to consider the design, technology, innovation. In that, you get a technical skill that you build up, so it could be engineering or it could be science or it could be IT. You build up a technical skill, but you also build up the innovation and business type skills as well. That is one that you can combine with other degrees. There's various ways to combine these things if you want to, or you can do it as a standalone degree.
Excellent. That was going to be my next question. Thank you.
So here you can sort of see, while we list out all these specializations in engineering, there is a lot of overlap between different disciplines. So for example, if you take robotics engineering, that you can sort of see sitting in the middle left-ish there, that's the one. You can see it's got overlaps with all sorts of things there. So robotics itself, during that degree, you will learn electronics, you'll learn some mechanical engineering, you'll learn some software engineering. And see, the way that it's structured, you don't even see all of those connections in this diagram. So even this is simpler than what it really is. What that means in these situations is that you have skills in all of those areas. So you're not just limited to, say, once you finish, if you've done robotics, you're not just limited to jobs that are listed as a robotic engineer. You can go for things in the electronics space, in the mechanical space, in the software engineering space. So you've actually got a really broad set of skills. Just something to keep in mind, that there's lots of flexibility once you get out into industry as well.
And let's say, for example, I started robotics engineering, but then I was doing some electronic topics and I decided that I preferred that. Would I be able to have flexibility to change specialisations?
Yes, absolutely. Well? Yes. So all of our degrees are set up so that most of them, there's a couple of variations, but for the most part, we have a common first year. So it doesn't matter which engineering degree you start with, everyone does the same thing in first year. So you basically get a taste of all of the core engineering skills. So you'll do electronics, you'll do software engineering, etc., some mechanical, some professional skills. Everyone does that. So it does mean that at the end of first year, if you've enrolled in one thing and you discover that actually you really love something else, it's very easy to do what's called an internal transfer and move from one degree to the other.
Excellent.
There are a couple of exceptions to that rule, things that have a bit of a niche requirement. Things like biomedical engineering has a physiology topic that you're not going to do in any of the other engineering degrees. It doesn't mean you can't do an internal transfer, it just means you'll have to negotiate how you're going to pick up whatever you might have missed,
of course,
etc. Yeah. So there's still ways to do it. You just need to have those conversations with us.
Excellent. Yeah. Thank you. Now, I understand we're going to chat a little bit more for people like myself who might not have any idea what some of these specialisations mean, about having a look at breaking them down a little bit more. So I'll definitely leave that part to you.
We're just going to go basically in alphabetical order through our huge list of options.
Great.
Now, I will say up front though, and I think we reiterate this at the end, don't feel too overwhelmed by all of this, because for one, you can do those internal transfers. So if you do start in one thing and want to change, that's an option. We also have a flexible entry option. So if right up front you just have no idea which type of engineering you want to do, you can enrol in our flexible entry degree instead, and then you don't even have to make a choice until the end of first year. So keep this in mind, but don't feel too overwhelmed by the amount of information coming your way, I think. So biomedical engineering has a strong focus on healthcare. So you're looking at, there's all sorts of things that fit into this space. Basically, if it aligns with healthcare, it's probably somewhere in the biomedical engineering space. So looking at things like, we have a real strength in biomechanics here. So that's looking at how the body moves. So looking at how we can build prosthetics, how we can support joint health, how we can do all those sorts of things. We've got a big area in research in that, which means as a student you can access that knowledge, you'll learn about that in your degree. Assistive technologies is another cool one. So you can kind of see in the photo here that we have this ball-looking thing. This is Orbi. It's a game controller that was designed for kids with cerebral palsy. So it's got that health connection because it actually gives haptic feedback and helps kids to improve their fine motor skills through using it. So it's not just a game controller, it's actually improving their health outcomes. Yep. So that fits into my biomedical engineering as well. So there's also things that are software focused, so building training simulations and things like that. If it's got a health focus, it's biomedical engineering. Yeah.
Excellent.
So you can see sort of a list of jobs out there. That's just some of them. So you could be looking at designing new equipment, you could be looking at maintaining existing equipment, you could be working privately, you could be working for government. It's really broad. There's lots of opportunities out there. Yeah.
Excellent. Sounds very interesting. So it's like gaming with a purpose. That's Orbi.
Some of it, yep. Some of it.
One area that you could go into.
Yeah, that's it. Yeah.
Excellent. Thank you. And what about civil engineering?
Civil engineering, we're looking at really big scale stuff. Basically the infrastructure all around us in the world, so the built environment, water resources, mining and transport. We're looking at big, dirty, noisy stuff. It's good fun. And this is one of the spaces where we actually have a specialised pod that is separate from our main Tonsley building, where you can come and study all of this sort of stuff just because of the scale of what's required. So that's really cool. So, I mean, civil engineers are going to be required everywhere. Anywhere there's people, we have infrastructure and we need people to build that, design that, maintain it.
Yeah.
Like our lovely big roadwork kind of situation down here at the moment. Like that's requiring a lot of civil engineers. It's a big, impressive engineering feat and it's going to outlast, lots of us is the idea. So, civil engineers have to look a long way in the future and be building something that, is going to be robust and is going to stand the test of time. So, it's quite a cool place, quite a cool area, and it's one that there's always going to be job opportunities because we are always needing that sort of stuff.
There's so many roadworks and improvements happening in Adelaide at the moment. I'm sure there's a lot of jobs in the area.
Yeah, absolutely. Computer and network systems is another cool one where we're looking at software and hardware and the interface between them. So you do get some of the software engineering side of things and some of the hardware combined. So looking at things like embedded systems, mobile computing, all those sorts of things where you have pretty specialist software and operating systems, etc. But you also need to understand the electronics behind it all and how we convert, those electrical signals into useful software and things that people can interact with. So there's lots of, I guess, nitty-gritty stuff that you need to understand down at that low-level interaction between the software and the hardware. So anything I haven't covered there? Not really.
So as a non-tech savvy individual like myself who studied psychology and engineering, this isn't looking at app development. This is looking at much smaller, isn't it? So more like the systems interface.
That's right, the interface between the hardware and the software.
Yeah.
So it's one thing to build a piece of hardware, but if you can't then convert, all the outputs from the sensors or if you can't convert that into something useful that people can access via some software, then what's the point?
Great.
So that's why we're looking at specialised embedded systems. So it might be like robotics. They need little onboard systems that can do things that don't need to link out to a bigger system to do all the computational stuff. You want to do that right there locally. So that's going to be a specialised embedded system. So you potentially would need to be designing the circuit boards yourself and then writing the software that connects to that converts that to something useful. So it's quite involved, but it's very cool and it's definitely in demand. The more we're automating things and needing networks. Yeah, that's it. And so no, there's lots of things. They're also broad, like there's so many applications for all of these different things. Yeah, that's quite a cool one. If you're into the software and the hardware, if you like to write code but you also want to design your own systems, it's a perfect sort of meshing of those things.
Brilliant. Okay, so that might be the right one for you if you're interested in that area.
Yeah. So electrical engineering. So I mentioned we have electrical and electronic engineering at Flinders, and they're both related to each other. Electrical engineering, we're interested in the large scale stuff. So how do we generate electricity? How do we do that sustainably, safely? How do we transport it from where we're generating it to where we want to use it? So we have a couple of specific niche areas where we we have specializations that you can focus on. So we have renewable energy systems and we have electrical drive systems. So the renewable energy systems, as it sounds, looking at solar panels, wind farms, all those sorts of technologies. And electrical drive systems, we particularly have a strength in the area of marine vessels, but we've got another degree that connects with that as well that I'll talk about a little bit later. But electric vehicles, all that, motors, things like that. So there's two, they're fairly distinct kind of areas, and you can choose which one you're most interested in. You'll learn about a bit of both, but you can get a bit of strength in one or the other in particular if you have an interest like that. So yeah, again, we need electricity, we need, it's another skill that's always going to be in demand. While there's, civilization around us, we need electrical engineers. So
excellent. And what is the difference between electrical engineering and then electronic?
Yes, so electronic, we're talking small scale stuff. Okay. So rather than being interested in generating the electricity itself, we're more interested in how we can use electricity to send signals from one place to another. So we're talking much smaller scale stuff. We're talking circuit boards, so you can connect to things like robotics, but not necessarily, but there's lots of connections to robotics. It's one of those really diverse kind of spaces. So circuit boards for all different purposes. And actually what's quite cool about this is we have a really strong electronics industry right here in Adelaide. And people sometimes don't realise that, because even though we have stacks and stacks of little companies around the place, they're all direct to consumer. So they design things and sell them directly to the people that want them. So they sell directly to other businesses. They don't build things that you see on retail shelves. So often people aren't aware that we even have this thriving industry right here in Adelaide. Wow. So it's definitely in demand locally, which is something, for some of the other degrees, it's in demand, but it might be interstate or in particular locations. This one's right here in Adelaide. Like there's tons of opportunities. But it's the sort of thing that, we take electronics for granted. It's all around us, our phones, our white goods, our cars, like all of those things have electronics in it. So they all need electronic engineers. There's loads of opportunities to.
Yeah. Excellent. I know how much we were saying we struggle sometimes if we forget our phone for the day. So there you go. It shows how important that area is. Now, you've mentioned robotics a few times. Yeah. So you can do an entire specialisation on that as well.
Absolutely. So robotics, you can combine, you combine electronics, you combine mechanical engineering, and you combine software engineering. You need to know all of those skills to effectively work in this space. So robotics and automation is a big part of this as well. So the more, industry is moving towards automating systems that are, either dangerous or repetitive or just straightforward, automating all those sort of systems so that we can have our human workers focus on things that are more variable or require more critical thinking and things like that. And the more that we're doing that, the more we're going to need people with expertise in this kind of space. Again, not just you're going to need people to maintain that equipment, you're going to need people to design new systems, and this is something that, again, government and private sector are both employing people with these skills. But like I mentioned earlier, because you have those diverse skill sets, you could potentially branch off and work in the electronic space or work in the mechanical engineering space, or you've got those skills, so you've got those options. But excellent. Yeah, we have some specialised teaching and research labs in the robotics space, which is really cool. So if you're keen, let us know. We can always get you in and show you around some of those places too.
Excellent. That sounds very interesting. And what is pictured here? What are we looking at?
Yes. So I'll start with the top, but then I'll explain the bottom one properly. So the top, where we've got a whole bunch of people there in the lab, you can see kind of tucked in there, we have a couple of robots with eyes on. So that's Baxter and Sawyer, and they are what we call cobots. So they're collaborative robots. And the idea is that they're actually safe to work directly alongside. They don't need to be behind a protective barrier like a lot of industrial robots have to be. Because as they're moving around, if they encounter a force they're not expecting, they detect that and they stop. So they're intelligent in that kind of way. They can also be trained without you needing to have programming skills. You can put them into training mode and move them around to show them what you want them to do and play it back. So that's pretty cool.
It's good for someone like me.
Yeah, it can give yourself a robot hug. Yeah. So those sort of things, we're expecting that, in future there'll be more of that style of robot happening. So it's important for our students to get familiar with how that works versus a more traditional robot setup. And the one down the bottom is actually a biomedical tool. So it is a robot. It's used in biomedical engineering. It's from our biomechanics lab. This is our hexapod, and the idea with this is that you can put a prosthetic, a limb replacement, or an actual limb from
human
often
body.
a human body. You can put a donated one in there, and that hexapod can move it around in a natural way, and you can take measurements on wear and tear and see how joints behave in certain conditions, and that helps us learn more about, you know, how our bones, our muscles, our cartilage breaks down, how it wears, and therefore how can we prevent that? How can we build prosthetics and replacements and things like that that are going to last longer and be accepted better by the body? And we can test those things that we're building in this same scenario. This is a really cool tool because it's actually better than gold standard for the industry. So it performs above gold standard for the industry, and it was designed, built, everything in-house here at Flinders. It's completely ours, which is really cool.
Yeah, and I can see that overlap that you were talking about earlier between the different specializations in engineering coming out there, like biomedical and robotics.
That's right, yeah.
Excellent. So, mechanical engineering.
Yeah, so this is another really nice broad degree that you can apply in all sorts of different areas. So if it has moving parts, a mechanical engineer can build it. It's kind of, yeah. So you're looking at, it's so broad. Even when I ask the academic stuff to tell me more about it, it's so broad. It's hard to define.
Narrow it down,
yeah, that's it. But I guess you look at things like properties of materials so that you understand how things move, when things break, all this sort of stuff so that you can understand what materials you would use for various projects. You look at fluid and aerodynamics, so how do things move through different situations, excellent. So underwater or in the air, how do we design things that are aerodynamic and move efficiently, but you look at all the mechanisms for movement as well, like you learn tons, it's very cool. You can sort of see almost any industry, like mining, defence, manufacturing, all these sorts of things. Everyone needs mechanical engineers if they're building stuff that moves, structures, parts of these. So having a look at the pictures on the side there, some of these are all linked to student projects and student groups. So the very top little image there is a warm and cup robot. So this is a team, our students do this as part of one of their topics. So it's an engineering design topic that they do. And as part of that topic, they take part in the warm and cup competition. So they work in teams, mechanical and robotics engineering students work together, and they have to design a robot that can complete a set task. They're timed, there's usually something really tricky about the task. So in that top one, you can see there's a gap in the table. They had to have their robot be able to get to the other side of the gap, but not leave a bridge behind. So whatever they put down, they had to be able to pick up and keep going. So there's robotic elements and there's mechanical elements, and they had to pull all that together.
Wow.
The best team from Flinders then goes off to compete against other unis, so it's good fun, like that nice competitive edge, but it's a good fun way to test all their skills.
Good motivation.
Yeah.
And the car.
Yeah, now this is really exciting. So this is our fast solar car. The team working on this is a combination of students and staff, and not just engineers. It's broader than that. There's business students, there's IT students, there's all sorts of things, because this is a huge project. They have to raise money, they have to design the car, they have to build it, like everything. These guys are taking part in the Bridgestone Solar Challenge in October, so they are just sort of finalising preparations to take off up to Darwin and race their car back down.
And they come drive. They drive back down to Adelaide.
Yeah, that's it. Yeah, so it's got to be fully solar powered. They've entered the passenger vehicle class, so it's got to take a certain number of passengers. So it's like a road vehicle rather than a race car. Okay. So they're looking for the practical, everyday kind of car with this technology in, which is it's really cool. So they're doing really well, and fingers crossed that
they win.
they have a good race this year.
That's
so
really
very exciting. They've been putting a lot of work into that. But that's a really great challenge because you're going to need people with all sorts of different backgrounds. Obviously, a lot of mechanical engineers because you're building a car and that's got lots of moving parts and lots of structure, and you need to understand all that. But there's also software elements and things like that. So it is a multidisciplinary thing.
Excellent.
Yeah.
I understand that mechanical engineering has also recently been accredited for shipbuilding. Is
that
right?
Yes, that's true. It's our first degree to have that accreditation.
And it's one of the first degrees in Australia?
Yes.
How exciting.
Really cool. And we've got a whole bunch of our other engineering degrees that we're expecting to tick that same box very shortly.
Excellent.
So this is the first one out of the...
And that's huge with the recent collaboration in the Defence Force and everything like that. So there's a lot of jobs coming out in Adelaide in that space as well, everyone. So good one to keep an eye out on.
That's it.
And in line with that,
here we are, Maritime Engineering. So this one is one we're expecting to have that same accreditation soon. So this one you do 2 years with us, and then you do your final 2 years over in Tasmania with the Australian Maritime College. So you start off here, then you head over there for 2 years, and then we try and get you to come back here again.
Yes.
You know, we want you to stay here. But no, it's a really cool collaboration. So you get to come here, and again, this is another one where we do a lot of the stuff out at the pod. So we've got our large scale stuff. We actually have an immersion tank out there, so you can be building various components, from smaller maritime kind of robots to larger scale stuff, being part of the larger scale projects, and we can actually test them in that immersion tank, which is really cool. So looking in this degree, while we have a big interest in the boats themselves, it's not just the maritime vehicles, it's also teaching you about the facilities and the installations and things like that, which are the static structures as well. So there's a lot that you're learning. If it's to do with the ocean, you'll learn about it in maritime engineering. Yeah.
Excellent.
And once you finish your 2 years with us and you transition to your 3rd and 4th year, you then can specialise in naval architecture, ocean engineering, or marine and offshore systems. But once you've had the 2 years with us, you'll have a better understanding of exactly what all of those mean.
Yeah.
But yeah, just different focus on the different sorts of areas that you might be interested in.
We've had a good question as well from someone at the webinar, so thank you very much for your question. So asking whether in these areas, so the specialisations that we're going through this evening, if there are additional choices to specialise. So if someone was specialising in mechanical engineering, do you then get to, say, select aerodynamics as the example that's been given here, or for accreditation purposes, is there a set program of topics that you need to follow?
A little bit of both. Like some of the degrees have named streams within them that you can select.
Yeah.
Most of them don't have that, but they have flexibility in the electives. So if you had something you were particularly interested in, you could choose all the electives in that kind of space and build your skills particularly there. But in those cases, you won't come out with a differently named degree, but on your transcript it will show what you've selected, and that'll back up what you're saying you've got specialisation in.
And in that, it always often comes down to how you market your qualification in job interviews and things like that as well. So as Marissa was saying, if you have chosen to do a number of electives, say aerodynamics is the example, I could be wrong here, but in something that you were really interested in, if you had undertaken additional electives, you could obviously speak to that in a job interview, for example, and highlight all of that additional knowledge that you have gained from doing those topics.
The other way that we'd really recommend you customise your degree for yourself is in your project selection. So there's a lot of project-based topics. So you try and pick a project that aligns well with where you want to head. And also in that compulsory placement, that industry placement, at our part, so we have a whole unit that works, the WIL unit, that works to connect you with industry. Let them know exactly what you're interested in doing, and they will try very hard to align your placement with where you want to go. Those are your two best ways to specialise in that sense.
So it sounds like there are a lot of ways to really personalise your degree, which is great. So thank you, Marissa. If you've got any more questions on that, we'll definitely get back to you at the end of the webinar as well. But for now, we'll move along to one of the final ones, I believe, the final specialisation.
Yeah, so software engineering is a bit of a different flavour to the others, because obviously it's software, rather than building physical things, you're more involved in building the software to run things like that. So you actually can focus on electronics or computer science depending on what part you're interested in. So the electronics is going to have more of a focus on sensors, microprocessors. So if you've played with Arduino type stuff, or control systems, so all of that, it's almost overlapping with the computer and network systems degree that we talked about earlier. It's got a bit of that kind of flavour, but the focus is more heavily on the software, if that sort of makes sense. So lots of these have overlapping areas, but the focus will be different. So that's why it's a good idea, if you've got a particular interest, to have a chat with us and we can kind of recommend which one might be most interesting. And computer science is where you're more interested in the software itself, but you're looking at some real nitty-gritty in there. So human-computer interaction is a really interesting space. So different ways that we interact with technology. So you can see an example here being the VR glasses and the haptics device there that she's holding. So in that image down the bottom, the VR, obviously she's right immersed in a virtual environment, but then that haptics device that she's holding actually lets her feel what's going on in the virtual environment as well. So those are some really cool interaction technologies, and you would learn not just how to, you'd learn largely how to program apps and experiences and things software for those environments, but you'll also learn about the hardware that it's based on as well, because to develop software effectively, you need to have an understanding of what you're developing it for. Databases, network systems, there's lots of different electives that you can choose to sort of customise this degree. The big difference, I guess, between software engineering and the IT and computer science type things that we're not covering today, but software engineering has a bigger focus on the project management cycle. So all of these engineering degrees, you're going to learn really strong project management skills, and that's included in a software engineering degree. It's less so in a computer science or IT degree. Okay. So it's that management skill, all that sort of stuff that sort of makes this a bit different. So you're interested in the whole life cycle of software, not just the building of it, just the one part.
Yeah. All right, excellent. There's so many different options to choose from, and that one's a good example of one that I guess you do get to choose between the specific niche areas within that specialisation.
Yeah.
Now, we have sort of spoken about this a little bit. Obviously, there are so many different specialisations within engineering and then different areas within that as well. Yeah. And you did mention how there's the common first year, and you touched on the flexible entry engineering. So for those of you, if you didn't hear that earlier on, Marissa mentioned that there is a 1-year degree that you can start in with flexible entry, and that allows you to sort of taste a number of the different specialisations and then choose which one you prefer to specialise in, with hopefully adding minimal time onto your degree. But we do also have the Bachelor of Engineering Science.
Yes.
So how does that differ? I mean, I know, and I can also explain this from your perspective.
That's okay. Yeah. So Bachelor of Engineering Science is designed as a pathway degree. So if you didn't get the ATAR or selection rank now, selection rank that you were hoping for, or not quite high enough to get into one of the named engineering degrees, or if you perhaps decided you wanted to do engineering a little bit later on in your studies and you don't actually meet the maths prerequisites, so we'll talk about prerequisites in a little while.
Yes.
But if you don't meet the prerequisites in one of those sort of areas, then Bachelor of Engineering Science can be an option to get your foot in the door. So it has a lower entry rank. It doesn't have any prerequisites. You can start with us. It has topics to help build up your maths and physics skills to prepare you. And at the end of first year, you can transfer directly into second year of the named specialisation that you might have been aiming for in the first place. Fantastic. So the goal is that you shouldn't lose any time. You can still end up graduating after 4 years with a named Bachelor of Engineering Honours specialisation, like you would have if you got on straight into it. But so that you can see there it's got particular specialisations, and if there was something outside of that you're interested in, you'd have to negotiate with us exactly how to go about doing that. But there's always a way.
Excellent. So essentially, when you start university, regardless of what degree you're in, once you've completed at least 4 topics, you're given what's called your university grade point average, or a GPA, and you can use that score to apply again for any other course. And that's regardless of how you initially gained entry into university. So even if you were looking at something like Maritime Engineering, which isn't in this list within engineering science, and you didn't meet the prerequisites, you could still start in engineering science and transfer based on your grade point average at uni. It might just mean that you have to do a few extra topics to sort of catch up and meet the prerequisites.
Yeah, and there's options for doing
that. Yeah, chat to us and we can help you with that for sure.
Yeah.
Now, the program of study for these courses, you've touched on this a little bit already. What does a typical first year look like?
Yeah, so I sort of talked about this a little bit. That's okay. I got a bit ahead of myself, a bit overexcited. So everyone who does engineering will do an electronics topic. In that electronics topic, you practice the technical skill of soldering a little circuit board together. So you get assessed on that, and then you use that in a programming assignment. So you have to actually, so you want to do a good job on that board, because then you're stuck with it for your next year. But it builds up those, you want to do industry level soldering. So even if you've done soldering at school, this is probably just a little bit fussier perhaps, a little bit more precise than what you might have done before, and you'll learn what all the industry standards are. So everyone does that. Even if you do software engineering, you will do this electronics topic in first year. Professional skills is another topic everyone does. That helps you with report writing, presentations, all those sorts of skills that once you're out in industry, you're going to be expected to be using, and throughout your degree. So it's aiming to sort of get you off to a good start. Engineering design, so looking at how you take a problem, break it down into manageable chunks, design all those out, all that sort of planning stuff. Engineering programming, so some coding, that is, again, relevant to most engineering degrees. And even if it's not directly relevant, perhaps you think to yourself, you're likely to later on be working in a team where it's relevant. So you need to understand how everyone else sort of fits in there. So it's good to have that under your belt as well. There's physics and materials. Again, similar thing. You might think, oh, but I'm doing electronics. How do I don't need that. But you'll find that actually it's very useful for all of them. Right. Engineering, mechanics and maths. So yeah, building up all your sort of fundamental skills in first year, all of that is relevant to pretty much every engineering degree you can do. And if it's not directly relevant to you, it will be directly relevant to people you'll be working on teams with. So you need those skills. But this is the way it's structured so that it enables you to do those internal transfers and switching between degrees at the end of first year if you need to, because pretty much it's pretty solid there. Like I mentioned before, from second year you'll be based at Tonsley, and that's where your really specialised topics start. And just reiterating that every engineering degree there, we have a 20-week work placement.
Excellent.
I think we've covered why that one's,
haven't we?
Yeah, why that one's particularly good.
Excellent. So I'll just mention this briefly, how you can maximise your degree. So Marissa has mentioned earlier that there are a number of different combined degree options. There are so many within science and engineering. You can essentially combine any science and engineering degree together. Design, technology and innovation is just a really nice one because it kind of adds something else that's got a bit of business in there as well. So that might be something to consider if you're interested in that area. Any degree, you can add something called a Bachelor of Letters onto that degree. It only adds 1 year to your total study plan, and we call it a Bachelor of Letters because it does encompass a number of different areas. We've got innovation and enterprise there as an example, but you can actually do the Bachelor of Letters to add a language onto your degree. So you could add French, for example, which is really good given the French collaboration that we've got with shipbuilding, for example. You can also study abroad to maximise your degree, and many engineering students do placements and things like that overseas as well. There is funding available for that, so come and have a chat to us if you're interested. And there's also further study available through a master's or a PhD in most specialisations. Anything to add there?
No, I think
we've covered it. Excellent. Now, applying to university, you may have already applied, but for those of you who have not, all applications are managed through SATAC, so that's the South Australian Tertiary Admissions Centre. They manage all applications for the South Australian and Northern Territory universities. Please make sure that you have submitted and paid for your application before the 30th of September, because after that date, there is a late fee that applies and there is no reason for you to have to pay that. So get your application in. You can still change your preferences around until the Wednesday, the 18th of December, before the main offer round on the 20th of December and the 10th of January. Sorry, there's a lot of dates there. Now, we've just got this table up to show you a bit of an example of some of the prerequisites that are required for various degrees within our College of Science and Engineering. We have circled the engineering honours part there because that does apply to all specialisations. Now, just note here that you do only need to have one of the ticked subjects required. That's really important. So you need either specialist mathematics or mathematical methods, not both. If you've done both, that's good for you. That's fantastic. Well but it is definitely not essential. So one of those, the expected minimum selection rank, or your ATAR, is 75 for all specialisations. You will also receive guaranteed entry if you achieve an 80 or above, which is fantastic. We've got some other courses up on the board as well, but we are holding a wide range of webinars at the moment. Some of these have already been and gone, but if you visit our website, search for webinars, you'll be able to find all of our previous recordings. We do have some other upcoming webinars on areas such as health science, criminology, sport, health and physical activity. We do offer a really wide range, so be sure to check that out. If you would like to get in touch with the prospective students team, you can give us a call. The number is just listed on the screen there, so feel free to screenshot that if you like, or you can email us at askflinders@flinders.edu.au. If we do have any international students joining us at the moment, just please note the different contact details that we have on the board. We're running this from the domestic recruitment team, so same information applies about the courses that you've heard about, but there is a different contact number there as you'll have different entry requirements thank you so much for joining us this evening, and thank you, Marissa, for joining us. I certainly could
Thank you
not
for
have
having
spoken.
me.
No problem. Could not have spoken in as much detail. Please get in touch with us if you have any further questions. Thank you.